Welcome to SOF IMO paper, Achiever section. I just want to clarify that this IMO is not the International Maths Olympiad paper or Indian qualifier. This is SOF. Okay. So I want to show the difference in SOF IMO and the IOQM or other IMO papers. So first we will finish this SOF paper, third section, that is Achiever section, which is carries more marks as I told you earlier. Okay. The first one is ABCD is a rectangle and M is a point on CD. Okay, AC and BM meet at X. It is given that CM equal to 3MD. Find the area of triangle CXM ratio area of triangle AXB. And other one is area of triangle BXC ratio area of rectangle ABCD. Okay, so let's first draw the picture. The picture looks like this. ABCD is a rectangle. Okay, AC and BM meet at X. Okay, AC and BM meet at X. Okay, M is not a, M is the other point on CD basically. Okay, and it is given that CM equal to 3 times MD. Okay, CM is 3 times MD. Okay, okay. This is the ABCDs. Okay, first one is AB equal to CD. Correct? It's a rectangle. So which is equal to CM plus DM. Okay. So CM plus DM is nothing but Cm by 3. So which is equal to AB equal to 4 by 3 Cm. Okay, the first point. In triangle CXM and AXB. Okay, this is what we are comparing, right? CXM and AXB. Okay, these angles are same, X angles, AXB and as well as CXM are same. Okay, next, because AB is parallel to CM, okay, and AC is a transverse. Okay, so ACM or XCM equal to BAX or XAB. Correct? This angle and this angle will be same. Okay. Angle here and angle here are same. Okay. Now similarly, AB is parallel to CM. So BM is transverse. So angle here, that is ABX as well as XMC or CMX will be same. So from angle rule, correct? Both are similar triangles. Okay, so the ratio of their areas will be squares of their comparative sizes, right? This we have used many times in the previous videos. So CM by AB I am taking because see here we know the values. CM is nothing but uh, AB is nothing but 4 by 3 CM. So CM by AB square, CM square by AB square will become 3 by 4 whole square, which is 9 by 16. Okay, so there are two answers A and B, 9 by 16 here. So let's see the second part now. Okay, area of ABCD is at least 4 times area of BXC. Why I am telling this? Okay, so second part you don't need to mathematically prove. See, let's say ABCD is a rectangle and AC and BD are two diagonals. Let's assume they meet at X. That is the best. At that time, uh, any triangle you take, which is CXB, if it is forming CXB, this is 1/4 of the rectangle, correct? So minimum area, that is the minimum area. Here BM is not even diagonal, correct? So the rectangle area, the triangle area here BXC will be less than the when BM is a diagonal, correct? If BM is diagonal, the maximum area a triangle will have is 1/4. Okay. Now here, if you see the options, two options here, okay, where 9 is to 16 is the correct answer for the first part. So second part you need which one is minimum 4 times. Okay, because here it is BXC area will be still less. The ratio against ABCD will be okay still less, right? So it will be not even one fourth, it will be less than one fourth. So you can see the answer here B as the answer. Okay, you don't need to do this further mathematically. Answer is B. Next. So this is a moderate. You need to little analysis you have to do. Otherwise, you can solve it mathematically. Okay. Now this is a question looks very big. You need to understand the OGs. OGs. Okay. In less than OG, OG is basically cumulative frequencies. If you have a set of data and you all the frequencies you make it in cumulative frequencies and draw them either less than from small to big or I mean increasing order or decreasing order if you draw it's called less than OGU or more than OGUs. Okay. So once you know what is OGUs then it's very easy to solve it actually. Uh, let's see first one. In less than OGU the cumulative frequencies are written corresponding to the upper limit, right? It's a less than OGU, so cumulative frequencies are corresponding to the upper limits of the classes of the given data. In more than OGU, it is lower limit basically. Cumulative frequencies are written corresponding to the lower limit of the classes. This is all theory basically. You can once you know this, it's very easy. On an OGU, point P whose y coordinate equal to n by 2, half of the total number of entries. Basically, you are at the middle of the frequency, cumulative frequency graph. Has its x coordinate equal to the median y of the data. Okay, this will become median y of the data, x coordinate. Two OGUs, one less than type and other more than type for the same data, when drawn simultaneously on the same graph, intersect each other at a point P whose coordinate x equal to n by 2, okay, and coordinate y is median of the data, where n is the total number of entries of the data. Okay. So once you know the theory, it's very easy. Its answer is A. Uh, okay. You need to understand these OG graphs. It's a theory question. Yeah. Just I said moderate because you just need to go a little more into the statistics. Okay. Now study the statements carefully. Statement 1, both the roots of equation, uh, oh sorry, this is x square, this is x square minus x plus 1 equal to 0 are real. Okay, let's find out. Statement 2 is the roots of the equation ax square, this is ax square, plus bx plus c equal to 0 are real if and only if b square minus 4ac is greater than or equal to 0. Statement 2 is straightforward, you can tell it is true because this is a determinant and it should be greater than 0 to get a real root. Otherwise, you will get imaginary roots. Okay, so statement 2 is true. 1, let's find out. So let's find out the determinant same. B square minus 4ac. B square is minus 1 whole square, which is 1, minus 4 into 1. Okay, so 1 minus 4 is minus 3. So obviously, this don't have a real root. So statement 1 is false. Statement 2 is true. That is D is the answer. Easy. Okay, now this one. The question is just match the following. So let's see. When an odd integer a is divided by 2, the remainder r can be odd integer, right? So when you divide it with 2, you'll get only 1. So q. Okay, all right, 1. This is the answer. When an integer a whose unit digit is 4 divided by 5, then the remainder r will be 4. Okay, a whole number lying between square root of 2 and 2 square root of 2 is it is 2. Okay, square root of 2 is around 1.4 and this will be 2.8. So between 1.4 and 2.8 you have a whole number which is 2. The digit at the units place of a number is 5, then it is surely divisible by 5. It is p. Right, so hope you got all the 4 correctly. So that's the answer. Easy. Okay, now two circles intersect at C and D. Okay, where O is the center of the second circle, AD is produced to cut the second circle at F. BD is produced to cut the second circle at E, and angles are given. Okay, find two angles ACE and COD. Okay, so this is the diagram given actually in the problem. Two circles, and then you have BC and AF as parallel, and then both circles are meeting at points C and D. C and D. O is the center of second circle. Okay, and some angles are given. If you see here. Okay, now let's see. It is given that angle DEF. Okay, DEF is 110 degrees. Angle ACB is 32 degrees. Angle DAB is 118 degrees. Okay. Now ABCD and CDF both are cyclical quadrilaterals. We understand. The property is opposite angles are 180 degrees. Right. So if you take first one, angle BAD plus angle BCD is 180 degrees because it's a cyclical quadrilateral, right? So which means BAD is given, right? BAD is given. Okay, so 118 plus BCD equal to 180. That means BCD equal to 62 degrees. BCD is 62 degrees. Next, angle BCA plus angle ACD equal to 62. That is nothing but BCD, right? Okay, BCA is given as 32 degrees. Okay, so angle ACD is 30 degrees. Angle ACD. Okay, this angle ACD is 30 degrees. Okay, okay. We are trying to find out ACE basically. Okay, so we have this angle, we have this angle, we need to find this angle now. That's it. CDE, if you find, we are done, right? So you sum ACD plus DCE, then we are done. Okay. Again, it's a cyclical quadrilateral. So angle BCA is same as BDA. BDA. Why? Because BA is a chord and it is subtending angles at C and D on the same circle. Correct? So these angles will be same. Angle BCA, angle BDA will be same. Okay? So BDA is also 32 degrees. BDA is nothing but EDF, right? Opposite angles. So that's also 32 degrees. Now next, in triangle DEF, okay, angle DEF plus EDF plus DFE, three angles are 180 degrees. So DFE is 180 minus 32 minus 110. This 110 is given if you see here, DEF is given. So which is equal to DFE equal to this angle is 38 degrees. Okay, DEF is nothing but DCE. How I am telling? DE is a chord. It is subtending an angle of DFE as well as DCE. Both will be same. Correct? So which is 38 degrees. So now you got 38 degrees here and angle ACD is 30 degrees. So 38 plus 30 which is 68 degrees is the angle ACE. Right? Okay. Now let's see the second part. Okay. AD and BC are parallel. BD is transverse. So angle BDA this side, okay, is equal to angle DBC here, correct? 32 degrees. BCD is 62 degrees. We derived previously. Okay. Next, in triangle DBC, this triangle, okay, angle CDB equal to 180 minus this angle plus this angle, correct? Angle DBC minus angle BCD, okay, which is nothing but 180 minus total is 94, okay, and which is equal to 86 is the BCD, right? Next, angle CDA equal to angle CDB plus angle BDA. That's correct. Sum of these two, 86 plus 32, which is 118 degrees. Okay. CDA is an external angle to, this is the external angle to CFD. If you take CFD rectangle, a triangle, CFD triangle, this is the external angle. CDA is the external angle, right? Which is sum of internal opposite angles, correct? Which means angle CDA equal to angle D, DCF and CFD, correct? These two angles. So DCF is nothing but DCF, okay, is same as DCE plus ECF, splitting of these two, right? Plus angle CFD as is I wrote. So DCE is 38 and ECF is 32, okay, plus CFD, okay. Angle ECF, how we got? It is nothing but EDF because ECF, EDF are angles subtended by the same chord EF. That's why. Okay. So angle CFD equal to how much we got? 48 degrees. Angle CFD is 48 degrees. Now you know we need to find angle COD, correct? So COD is twice CED or CFD, correct? Why? Because it is the same chord CD subtending an angle at center O is twice that of angle subtended on the point E or F, correct? So now COD is 2 into 48, which is 96 degrees. So problem looks very big, lengthy. You need to be careful in multiple calculations. That's why I would say this is at least hard. Okay. So that's all. These are the 5 problems, right? For the achiever section. And they looks okay. I mean, it's not rocket science. You can solve it. 10th class student can easily solve. You don't need a special very special practices for solving this. This you have to do your regular textbook and some Olympiad questions. Okay. Now, this video IMO SOF IMO I will end here. I will take next IOQM and I will show you how much different. IOQM is not so easy like this. SOF is very easy. Okay, this is a private body which is conducting the mathematical Olympiad. I will show you IOQM, which is the standard international maths Olympiad body. IOQM is Indian qualifier. Okay, when they choose Indian team, we have to go through multiple tests actually, 2 3 rounds of mathematics tests. So IOQM is the first level of test, and I will show you what is that first level looks like. This is level 2 here, but I will show you how first level of IOQM looks like. Okay, wait for my next videos. Thank you.